Hope you all can hear me loud and clear.
Yes, ma'am.
Okay, thank you.
Recording in progress.
So this is the second day school session of EEI3266, Information Systems and Data Management course. I welcome you all to today's session. This is the introduction to the session. So we are going to cover 2 units today. So Unit 2 on Unit 2 Session 4, which is on Introduction to Database, Degrees of Data Abstraction in Data Modeling. So here you will learn about data modeling, database architecture levels, weaves we call, and data abstraction layer, schema, data independence, type of database models. All right. So this data independence and data abstraction, those things I have explained in the lecture video, okay, which is uploaded to the LMS. So because we cannot cover everything today, I'm going to cover only the important aspects. If you haven't gone through the lecture video and slide sets, please go through it. And if you have any questions, there's a forum. You can put any questions you have regarding the day school 2 in that forum. Okay. And under Unit 3, Database Analysis and Design, we are going to cover Session 5 on Database System Development Lifecycle. There you will learn about Software Development Lifecycle, SDLC, and the Database Lifecycle. Okay. So can any one of you tell me what is Database Management System? Because we have got a slide I have done a slide explanation, and we have gone through a bit about DBMS in our previous day school. Or if you have gone through the lecture video, you know what is database management system. So can any one of you tell me? Yes.
Database management system is, ma'am, storing the data big in the where the customer is storing the data in server.
Customer?
No, I think database means FB multiple users are using the FB. The data collecting on the database, storing the.
Okay, so that is about database. Thank you for that explanation. Can any one of you tell me what is DBMS means?
That is a software that's allowed to communicate a user to with database.
Software, yes. Okay, good. Yes. Anyone else? Users data name, phone number. Okay, I cannot get what you are saying. Okay, so let's go through what is DBMS. So DBMS, as you can see in this picture given here, there can be a central database to have all the data stored inside. Okay, and there can be different users accessing the database. Right? So there's this payroll officer who needs to access staff details, and there's customer service advisor who needs access to customer accounts, and there's a sales manager who needs access to stock levels. So these different types of users need to access different types of data from the database. Right? So they are accessing it using this DBMS. That means database management system. Okay. Yes, Rashmika, that is a good definition. DBMS is a software system that facilitates the process of defining, constructing, manipulation, and sharing data. Okay. So what you need to get is the basic idea of what is a DBMS. So DBMS is a software application which is used for the users to access the central database. So these users get different views of the database. They are not accessing directly the table views. They are getting different types of views which they need, where they can get the necessary details they need. Okay, so that's why we use a DBMS to manage the data views of different users, right? Because this payroll officer, he doesn't need any details about sales. He needs about access details to staff. Okay, so he needs to access different how the information of staff, because he needs to calculate the payroll, right? So the DBMS is providing the access the payroll officer needs. And sales manager needs information about sales, the stock of the different, the inventory, right? So they need different views of the data inside the database. All those things are provided using a DBMS. This is an example of a DBMS, right? There's a ticketing company which allows customers to buy tickets online or through a booking office. There's one we are selling online sales, and another one which sells there's a booking office, right, where they can go and buy the tickets. This is online. So how can they use a DBMS to keep record of these sales? So this is option 1. As you can see, there are 2 separate systems. All right. So there's separate system for online sales and another separate system for booking office sales. And this is option 2, where they have one centralized system for both online sales and booking office sales. Right? So you have to choose what is the best option, whether it is option 1 or option 2, and the advantages of or disadvantages of choosing option 1 or option 2. If you choose option 1, what are the advantages and what are the disadvantages of choosing option 2? Right? Did you get the question? Or do I need to repeat? Okay. So this is option 1, where they have 2 separate systems, one for online sales and another one for booking office sales. Okay. And this is option 2, where there's a centralized system for both booking office and online sales.
Ma'am, option 2 is better.
Okay, why is that?
Option 1, there are 2 separate systems.
Mm-hmm.
It's very difficult to
Right. So can anyone help? Yes. Okay, so you have chosen option 2.
Yeah.
Anyone? Yeah.
Yeah. Yes,
Mhm.
ma'am. Absolutely.
Mhm. Yes, good. Okay.
It's cost efficient.
Mm-hmm. Good.
Option
We
1
choose
can lead
option
to
1. We have to check both systems.
Mm-hmm.
option
we-
1 can lead to data collision, and option 2 is a centralized database system. So there will be no data collisions.
Okay, good. Yes. Okay, so that's good. So you have anyone choosing option 1 or option 2? And any reasons? No one. So no one is choosing option 1. But there was one student, 1 or 2 students saying option 1 is better than option 2 in the previous weekday session. And she had a good logic there. So what she was telling is by having option 1, we can have what? So in a centralized, sorry? Yes. 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 So yes, that was what she was telling, and also by having 2 systems, they can manage the risk of failing at there's a 1 point failure, right? So if single point failure, so if that happens for the centralized system, if there's no backup, the system will be lost, right? But having 2 separate systems, they can like run the project, run the program, or run their system by at least 1 point, right? If the online system is lost, they can use the manual system, right? So there can be both pros and cons of having option 1 and option 2. Okay, so you have to think about that to see that. So anyways, so these are the pros and cons of having 2 separate systems, but most people use option 2 for using a centralized system nowadays, because mainly these are the questions which will arise by having option 1. That means using 2 separate systems. So if you are using 2 separate systems, how would you know which seats have been sold in each system? Think of a movie theater, right? When you go to a movie theater, you can do online booking or you can go there and buy a ticket, right? But if there are 2 separate systems for each, if you book online and when you go to the movie theater, so it is already booked by the booking office. Someone has taken. So what would happen? Because there are 2 separate systems, they don't know whether the seat has been booked by the online booking system, right? Because there is no communication between them. So by having option 1, there should be a 1 to manually check the online system as well, right? First, they need to check the online system, whether that seat has taken before giving that seat to a customer who comes to the booking office, right? Otherwise, you could lose customers due to errors or double selling the same ticket, right? No 2 people can sit on the same seat now, right? And by using a centralized system, this type of faults will not happen, because as the both systems communicate with each other, and that is on a centralized system, once a seat is booked online, the booking office officer also can see. He can see that seat is taken because it gets updated in the real time, right? And it is reflected. The modifications to the data is reflected real time. So there would be no such confusion. But of course, the option 2 would be more advanced, more complex, and it should be programmed properly. And they should put security measures to not have these intruders attacking the system, because it can be online, right? And they should put more security measures to the centralized system so that it won't fail. And they should also keep a backup system, right? But due to most of the today's systems are centralized systems without using separate systems. But in many government organizations nowadays also have these two separate systems, like they are writing it manually and also entering it to the system later on. Likewise, they are having two separate systems as well. But mostly even the railway system, they have a centralized system of a database, having a single database. Right? Any questions from that part? Did you get the idea of the advantages and disadvantages, pros and cons of having two separate systems and having a single centralized system? Yes? No? All clear? Okay, thank you. Then we will move on to the next section on database models. Okay, so the database model is something which describes the logical structure of a database. Okay, so it describes how the relationships and constraints are defined and how data are stored and accessed. All these things are defined in a database model. And individual database models are designed based on the rules and concepts. Right? We will see what are these database models. There are different types of database models. Right? So mainly there are three types of database models, as conceptual or high-level data models, representational data models, and physical or low-level data models. These are the three types. And if you have gone through the past papers, this was asked by a weekday student. So there's a question to write the types of database models and to give an example of each of the database type, each of the types, right? So this is the answer to that. There are three types, as conceptual, high level, representational, physical, and low level. And these are the examples for each type. There can be more for this, right? There can be more for conceptual or high level data model. There can be more models for representational. So these are examples of each of the types. Okay. So under conceptual or high level model, we are learning about ER model and object-based data model. Representational data model, there's relational model, hierarchical model, and network model. Physical or low-level model, we are learning about indexes, or we call indices, the plural. Okay. What is ER model? So also you need to know, under conceptual or high-level data model, which is used to give the design of your database, we learn in advance about ER model, right? And from here, we are going to learn more on relational model. We are using the relational model. And indexing, we are not going to teach you for this course because this is a level 3 course for first year students. And when you go to maybe second year or third year, you will learn about these advanced database concepts about physical or low-level data modeling on indexing and all. For now, you can get a brief idea about what that is. Okay. So ER model, we will learn more on day school 3, but now just get an idea of what is an ER model. ER model is used to graphically represent what we call entities, attributes, and relationships using an entity relationship diagram. So this is an entity relationship diagram, what you can see here. And in ER diagram, it consists of not just this, but there are so many entities and so many relationships among them. Entity is something which we call a real world object. Okay. So do anyone of you know what is an entity? Can you give me an example of an entity? Okay, table is a general concept. I am asking for an example of an entity, which can be a real world student. Okay, good, that is a good example. Okay, teacher.
Customer.
Okay. Customer, yes, good. So you know what entities are. Entity is something which is a real world object which we are going to take as a table actually in our database, right? So think of a student table, think of a scenario of a university. There are students and they are taking courses. So student can be one entity, courses can be one entity, right? And there can be a relationship between these two entities where a student takes a course likewise, right? And the attribute is the feature of that student which we are going to keep in our database, right? So we need to keep the information such as name, age, date of birth, what else? Student number, registration date, and all these information we need to keep about a student. So all these information which we need to keep are the attributes of that student. Got it? And grades, when he said sit for exam, we need to keep his grades. Okay. And about courses, we need to keep about course ID, course name, the academic coordinator who's teaching the course. Likewise, so all the information which we need to keep about that entity are the attributes. Okay. So if you didn't get that idea, don't worry. We will go into more detail in the next DS2 session, how to, what are these entities and different types of entities, types of attributes, types of relationships. There are so many things which we are going to learn about these entities, relationships, and attributes. Okay. Next, the object-based data model. So there are two object-based data models. One is object-oriented data model. Other one is object-relational data model. And object-oriented data model is based on object-oriented concepts like identity, encapsulation, polymorphism. There are so many object-oriented concepts which you will learn in the second semester object-oriented course. There's another course. Okay. For now, just get an idea, a brief idea about what is object-based data model. And also, it is used by object-oriented programming languages such as C++ and Java. Okay. And object, just the same as an entity, object is a real-world entity. And the specialty is it has two things, one called state and the behavior. Okay. And object-oriented database enables permanent storage of objects in a database. Then these objects act as persistent objects and exist after program termination. So they can be accessed later and also can be shared by other programs. And relational model, object relational data model means it is with enhancement of object-oriented data model. The relational model with the enhancement of object-oriented data model we call as object relational model. Okay, so just keep a brief idea that there are two types of conceptual or high-level data model as ER model and object-based data model. And under object-based, it can be divided in two types, object-oriented and object relation. That's all you need to remember. Just keep a brief idea about object-based data model, and we are going to learn more detail about ER model. Okay. Any questions? Okay. No, I guess. Then we will move on to the next category, which is representational data model. Okay. Representational data model. Under representational data model, first we will learn about relational data model. Relational data model means it represents data and relationships between data using the concept of tables. So relations, it is just like a table. And the table consists of columns. So the important aspect about a relation other than a table is that all the columns, these are the columns, name, UID. So they are the attributes in an ER model. We take them as columns in our table, but these should have unique names and unique rows. So 2 rows cannot repeat in a relation. In a table, you can have any number of repeated rows and maybe the same column name, but in a relation, there are some features, unique features to a relation other than a table. Okay, so table is also known as a relation. This relation name is given first. So this table name or relation is called student, and there are a few columns in that. Each column has a unique name and unique rows. Unique row means all the data in this row, that means Ramesh Dev, there's a user ID, mobile, that is particular to this student. Okay, and there's another row containing which we call as an instance. Okay, this is one instance of a student. And this is the second row is another instance of a student entity. Okay. And a column corresponds to an attribute and row represents a record that typically corresponds to a real world entity. Okay. So there are different names which may be new terms to you. Basically, a relation is called a table. Don't worry, you will learn these terms more and more when you come to the next day school sessions, and you will get familiar with them. All right. And column names we call as attributes or fields, and the rows we call as tuples or records. All these names are similar, and you will get this list of terms which we use. Okay. And before going to the next one, I need you to see this video on relational data model just to get an idea. It is too advanced for you now, but anyways, just so that you can get an idea, just watch this video. Okay. Don't worry if you cannot understand everything being said in the video. Okay. Let me know if you cannot hear the sound. You can hear the sound, right?
Yes, ma'am.
Yes, ma'am.
Designing your data model. In this video, you'll create the foundation for your clinic's custom app by learning about relationships. You'll also create an entity relationship diagram, or an ERD. While planning your custom app, you created the following goal statement. Design a mobile app for therapists to record services delivered to clients during their visit. And based on that statement and the needs of your clinic, you identified 3 tables of data: client, visit, and service. The next step is to identify how these tables relate to one another. Start by looking at the client and visit tables. One client can have multiple visits over time, but each visit belongs to only one client. This is called a one-to-many relationship. When creating your data model, use a crow's foot to represent a one-to-many relationship. One client, many visits. In order to relate these 2 tables, each visit needs to know which client it belongs to. But using something like a name or a combination of fields can be problematic. What happens if there are 2 Jane Smiths in the client table? It becomes unclear which Jane Smith went in for the recorded visit. Or what if Jane Smith changes her name to Jane Doe? The visits would no longer match up since the visit record still shows Jane Smith as the client name. And a misspelling in either table would also impact the matches. Instead, using a unique value that always exists and never changes solves the problem. When a unique value is used, it's called a primary key. This means that the client table will only have one record that identifies as client ID 101, who in this case is Jane Smith. The client ID will be unique and only assigned to Jane Smith. If that value is referenced in another table, that's called a foreign key. Client ID 101 in the visit table is foreign because it did not originate from the visit table. It was unique to the client table. You'll see that Client ID 101 repeats in the visit table to track every instance the client visited the clinic. As a best practice, it's a good idea to have a primary key in every table, even if you don't expect to use the primary key in a relationship. This prepares your tables for potential relationships as your custom app grows. It can also be a great way to reference any specific record during development and when troubleshooting. Another best practice to help you identify when a foreign key is needed is when you see a crow's foot in your table relationship. This is a good indicator that you'll use a foreign key in that table. Similar logic can be applied to services. A service can be defined as the actions the therapists take during a specific visit. While services are tied to a client must come into the clinic for a visit in order to get the services. One visit can have multiple services, but each service belongs to one visit. Just like client to visit, the one side uses a primary key. The visit and services table are related by the visit ID, a unique identifier for each visit. A client can have multiple visits, and a visit can have multiple services. By drawing out your data model using tables and branching lines, you created an entity relationship diagram, or an ERD. An ERD will become the foundation for building your custom app in FileMaker Pro. While writing out a plan helps describe the business problem, drawing out an ERD helps to explain what tables are necessary and how those tables will relate to one another. In this video, you learned about the one-to-many relationships between clients and visits and services. You also learned to create primary keys and foreign keys in order to relate your data. In the next video, you'll
Okay, so there was some other concepts which you haven't already known about primary keys and foreign keys, which you will learn later on. Okay. So no need to worry about those things now. It was just for you to get an idea about why we are using these data models, ER modeling and all, in our to design our databases, right? And yes, so one student asked, yes, all these video links will be shared in the LMS, and this slide set is different from the slide set, lecture slide set. That was lecture slide set, and for the lecture slide set, there's a video explaining the lecture slide sets, and this is day school slide set. I will upload this recording of this today's session under the these slide sets. Okay, so you can get all these, access to all these in the LMS. Okay, next we will move on to the next model, hierarchical model. Hierarchical model is, it is as a tree structure. Okay, so every record has owner. And this tree is also known as database tree. And the tree structure diagram represents the schema for a hierarchical database in which boxes correspond to record type and lines correspond to links. And this model is efficient when the database contains large number of one-to-many relationships. Now you know with that video what are one-to-many relationships, right? So there can be one entity having many relationships with a certain another entity, right? So you will also learn about, this is one type of relationship. You will learn about it. For now, just think of this. The hierarchical model is usually used in this model is used when a database contains a large number of one-to-many relationships. Okay, so think of a department. A department can have relationship with employees and project. So this is like a tree structure. The department is the owner and these are child entities. Okay. So this is the model which we are using in a hierarchical model. And next one is network model. Network model is based on directed graph theory. That means instead of a tree, it uses graphs and provide more connections among the nodes. And similarly, similar to hierarchical model, it also uses boxes and lines to represent record and links. And the importance of a network model is it has the ability to handle many-to-many relationships. That means it allows more than one parent. So in the hierarchical model, there's one parent and the parent has many children. And also this employee can have many children, considering employee as a parent entity. So it is like a tree structure. There's a root and there are branches. But in the network model, there are many-to-many relationships between the entities. So there's a department entity having relationship with course, and then teacher, and student having again with course, and teacher having relationship with department, student. Likewise, there's many-to-many relationships. Okay. So that's it about models, representational data models. Do you have any questions about representational data models? No questions. So did you get the idea of what is a relational model, what is network, what is hierarchical model? Yes, no?
Miss, again, can you tell about the hierarchical model?
Yes. Hierarchical model uses a tree structure. Okay, so there's a tree structure. There's one entity having relationships with many entities. And again, there's this entity can have relationship with many other more entities. So it is unlike this one with having so many relationships among entities. It is as a tree structure, and there can be only one-to-many relationships. Okay, so that is the structure of a hierarchical model. And network model, not like hierarchical model, it has so many relationships with each of the entities. These are different types of models which we use to build our database. And so you don't need to learn more about this hierarchical or network model because we are learning about relational model. And relational model has all these types. So it has a one-to-one, single relationships, one-to-many, and many-to-many. So you will learn about what these relationship types and how they are being represented and all these things. And then you will know what is meant by this one-to-many, many-to-many, likewise. Okay. Shall we move on to the next part then? So next part is low level of physical data model. There we talk about access path and index. Access path is a structure that makes the search for a particular database records efficient. That means there's a path where you can search for a certain record in the database. And index is an example of an access path. Okay, it allows direct access to data using an index term or keyword. There's an index term or what we call a keyword, and we search for a data using that keyword. Okay? Indices or index is an example of an access path. So there can be, these data blocks are the things where data is stored inside a database. And using indexes, we can search for a data inside these data blocks. Okay, so this is something where this comes to the physical level of data storage in a hard disk. Think of a data storage in a hard disk, right? So you don't have to think much about this part. just know that there's something called access path, and index, it's an example of an access path, and it is used to search for a particular database record efficiently. Yes, exactly like a dictionary or something. And also a search engine where we search for a keyword, right? So this is regarding a database. So these things in the physical data models and low-level structure of a database, you will learn in an advanced course about database. Okay, not now. This is to just get an idea that there is a data model to represent the low level of physical data model as well. Okay. Now we go to the database architectural levels or views we call. And under that, we will learn about the 3-level ANSI Spark architecture, or we call it ANSI Spark. Okay. So this architecture, we are going to learn about database on database architectural levels. So there are mainly 3 levels, external or view level, which is the user level, right? So users see this external level of a database. They have different views. Different users get different views of the database, right? And conceptual level, it describes the structure of the whole database, right? There's a conceptual schema, we call. And there's the internal level, which describes the physical storage structure of a database. According to this ANSI Spark architecture, there are 3 levels of a database architecture, right? And finally, there's the actual database. So let's watch a video about this ANSI Spark architecture and let's see whether you can understand more. Right?
The ANSI Spark architecture. Where ANSI Spark stands for American National Standards Institute, Standards Planning and Requirements Committee, is an abstract design standard for a database management system, DBMS, first proposed in 1975. The ANSI Spark model, however, never became a formal standard. No mainstream DBMS systems are fully based on it. They tend not to exhibit full physical independence or to prevent direct user access to the conceptual level, but the idea of logical data independence is widely adopted. The objectives of the 3-level architecture is to separate the user's view. It allows independent customized user views. Each user should be able to access the same data, but have a different customized view of the data. These should be independent. Changes to one view should not affect others. It hides the physical storage details from users. Users should not have to deal with physical database storage details. The database administrator should be able to change the database storage structures without affecting the user's views. The internal structure of the database should be unaffected by changes to the physical aspects of the storage. For example, a changeover to a new disk. The 3 levels are: external level, user views. A user's view of the database describes a part of the database that is relevant to a particular user. It excludes irrelevant data as well as data which the user is not authorized to access. Conceptual level. The conceptual level is a way of describing what data is stored within the whole database and how the data is interrelated. The conceptual level does not specify how the data is physically stored. Some important facts about this level are: DBA works at this level. Describes the structure of all users. Only DBA can define this level. Global view of database. Independent of hardware and software. Internal level. The internal level involves how the database is physically represented on the computer system. It describes how the data is actually stored in the database and on the computer hardware. The 3-level architecture has the aim of enabling users to access the same data but with a personalized view of it. The distancing of the internal level from the external level means that users do not need to know how the data is physically stored in the database. This level separation also allows the database administrator, DBA, to change the database storage structures without affecting the user's views. There are 3 different types of schema corresponding to the 3 levels in the ANSI Spark architecture. The external schemas describe the different external views of the data, and there may be many external schemas for a given database. The conceptual schema describes all the data items and relationships between them, together with integrity constraints. Later, there is only one conceptual schema per database. The internal schema at the lowest level contains definitions of the stored records, the methods of representation, the data fields, and indexes. There is only one internal schema per database. The overall description of a database is called the database schema.
Okay, so that the speed was very fast, I know. But anyways, if you there's the link for that video, you can listen to it again, and also you can put the captions on while listening. Then you will get a more good idea about it. So anyways, what it is telling you is that external or view level is used so that different users can get different views. Like in the first example, which I showed in the very first slide, where there's a payroll officer, salesperson, likewise. So these different users can get different views of the database. They will not know about the conceptual schema or the internal schema of a database. Okay. So different, just external view means that is the view level where what the user see on the database. Also, different users have different views. Conceptual level, this level is designed by the DBA, database administrator. So he designs this level using different conceptual schema such as the ERs and also the actual tables. So all these come under the conceptual level of a database. Okay. And internal level, like the indexes, it describes the physical storage structure of a database. Okay. So these are the 3 levels, ANSI Spark architecture levels of a database. Just now get a brief idea about these 3 levels in a database architecture. Okay, and remember this diagram. All right. Next, now there was a word called schema, right? You may be confused about what is this schema. So schema is the structural view of a database. And usually this is represented by the high-level ER diagram. Okay, so this is something which is called a schema. Here it can be represented in many ways. This is not a ER diagram. ER diagram has specific symbols and for entity and for attribute, there's a symbol. For relationship, there's a symbol. There are different symbols, but this schema can be drawn like this as well. Right? So this is the table where the cost table is there and the attributes are given inside. There are so many different ways on which we can draw this schema or draw the ER diagrams as well. There are different methods, but we are teaching one of the standard methods. Okay. So for the physical database structure, in the internal schema also, they have such a way of representing the physical structure of a database. which we are not going to learn, but we will learn the conceptual weave or structure of a database. So let's learn more on what is this schema, right? Then you will get an idea of what we call this schema. Okay. What is database schema? So listen to this, what is being said here, and try to grasp what is a database schema. Okay.
Hi, I'm Jared Hillam. The other day I had somebody ask me, what is a database schema? This is a great question and something that I think should get its own video title. I explain it in other videos, but it's something that needs its own attention. In essence, the schema represents any kind of structure that we're defining around the data. This would include tables, views, fields, relationships, packages, procedures, indexes, functions, types, sequences, materialized views, queues, triggers, synonyms, database links, directories, XML schemas, and other elements. Without any of this stuff, it's easy to get lost in data. Imagine, for example, that I gave you access to a folder housing a bunch of data from different sources all jarbled together. Imagine trying to make heads or tails of such data. Now, with a lot of serious time and effort, you could eventually get to some kind of structure for understanding the data. That structure and its corresponding data relationships is what we would call the schema of the database. The application of that structure is something that each database vendor does differently. For instance, there are unstructured data stores which apply schema only when the data gets read. In other words, the data lives in its jarbled state, and we apply the structure to the query code. This is what's called schema on read. On the other hand, there are databases which force structure as a condition before data gets written. This is called schema on write. The method of how a schema gets designed can influence different behaviors in a database. For example, if a database schema is designed as a series of tables connected by primary keys, then it is likely something designed for reading and writing singular records, which is ideal for applications like Salesforce.com. However, if a schema has a central table connected to keys supplied by surrounding tables, then it's likely to be something designed to make read output highly efficient. This kind of schema is ideal for high-scale information delivery, which is called a star schema. When we're interacting with data, the schema of the data becomes an important topic. A good schema can mean the difference between a query lasting a few seconds to a query lasting many hours. And this isn't something that we can cheat our way around. The big data craze proved that lesson to the entire market. Many organizations jumped into Hadoop hoping for magic, but consuming oceans of data with no conformed schema just made for painfully slow analytics. To get a sense of this concept further, you may want to take a look at the analogy I gave at the beginning of my video titled What is NoSQL? Back when the Hadoop craze was at its peak and the emperor was still walking naked without anybody noticing, we had a new customer asking, why are we doing all this data modeling? Isn't data modeling an old concept? To which our solution architect said, I agree that data modeling is a long-tested concept, but it does work. Sort of like pi. Why do we still use pi? Isn't that an old method of calculating a circle? In other words, the concept of engineering an analytically focused schema will remain an important part of being able to feed information to a body of business users. Not only does it lower the processing time and cost, but it also reduces the code complexity of SQL queries. Incidentally, that customer is today another happy referenceable Intricity account. Now, generating a data warehouse schema is a process that requires quite a bit of iteration. Usually it starts with a series of interviews which provide inputs into some documentation assets. Those assets ultimately lead to an early trial schema which we call a conceptual data model. This can act as a backbone for determining development costs for the data warehousing project. Once a project is ready to say go on development, that early model will get iterated on multiple times. Often it will undergo the scrutiny of a room full of people attempting to ask questions of the model which it can't answer. This beefs up the model's resilience to being a representation of the business's fundamental building blocks for analytics. Once this model is vetted, it can then be physicalized into a database schema which the source data will be loaded and conformed to. Intricity specializes in this strategic process.
So, did you get an idea about what database schema means? So, the importance of having a database schema is, without having a proper database schema, even if you have a database and DBMS, we cannot find the important information very efficiently or quickly. Right? So, schema plays a major part. That means the design of your database. Overall design, before actually implementing database, you need to design your database. So based on the design only, it depends how you can access the data, whether you can access them very quickly or it may take some time to run these queries on databases. Okay, we call queries, they are the components or the things which we use to access the data in the database, right? So to filter some of the data which we need. So to filter that, we write what we call database queries, which you will learn. And we use the SQL, which you are going to learn as the programming language of this course, the structured query language. We use that language to write these queries to retrieve the data from the database. Okay. Yes. So for example, there's a university database and there's external schema, conceptual schema, and physical schema. So external schema, they have mainly the views of different users, and it describes the end user interaction with the database. That means the people who are using the database on a very high level, not like the DBA, database administrator. And conceptual schema, we call it as the logical schema. It is a conceptual model of the database and it specifies the logical constraints or what we call the rules that need to be applied to the stored data. It represents how data is stored in the form of tables or entities and how the attributes of a table are linked together. Okay, so this is how it's an overall idea. For you to get an overall idea, this is how the conceptual schema is represented. There's this student table and there are some columns in that table. And this int is the data type which is used to store the data in this ID column. Other than integer type, you cannot store any other type of data in this student ID column. So int means you can use only numbers or numerical values. No any text is allowed in that field. Got it? So these are the rules or constraints we call, which we define when we design the database in the conceptual schema. Okay? Got the idea? And physical schema means it represents how data is stored on a storage system or disk storage in the form of files and indices. Indices means the index, right? And usually it indicates a storage allocation. That means the space allocated for that particular data. It is defined in terms of GBs or TBs, right? The physical schema represents these storage allocation, space allocation, and how these data is stored as files and indices. Okay, so this is an example. The relation stored as unordered files and index on the first column of students. So it refers to the first column of the students table. Likewise, we can define the physical schema. Okay, So did you get an overall idea about how these external conceptual and physical schema are defined? Is it clear? So what you need to focus mainly is about conceptual schema, because external schema and physical schema we are not going to learn in this course, level 3 course. Okay, conceptual schema is what we are focusing on during this course. External schema or weaves. Yes, external schema, these are called weaves. There are some SQL queries so that you can define these weaves. How users are going to see the different types of data in the database. Okay, so think of a payroll officer. He will get an external schema with a staff member with only his ID and the salary. And the salary he gets and any allowances he has. So the payroll officer needs only those information about the staff, right? And think of a human resource person. He may need other information more than what is needed by the payroll officer. He may need the age of the employee, the address, contact details, all these things will be needed by the HR officer. So he will get a different view of the employee. The main centralized table inside the database, it will have all this information. Okay, but different users get access to different components inside the same table. Got it? And also the weaves can be defined so that the user can get a weave from using different information from different tables also. Okay, so think of the payroll officer information, the information he needs to get. So it can be a combination of two or three tables. From the employee table, he gets the employee number. From there can be another table to store the salaries of each user. So the details from that table is also taken into his view. This is a concept, just get the concept into your head, but this will be, you will learn this in the next courses on database, how to write these weaves as well, how to write the external schema. But we will learn about conceptual schema, how to draw the ER diagrams, how to implement the tables using SQL queries, all these things you will learn. Right? So conceptual schema is the model, the logical way how the data is stored in the form of tables or entities and attributes, which I explained you earlier. Right? I already explained you how these how we take entities into a table where we take the attribute as column names. Likewise, you will learn it on the next day's code. Okay? Conceptual schema is the actual table we make, and external schema is derived from them. Yes, that is correct. That means external schema, conceptual schema is the actual design of your database with the tables which is inside the database. External schema is derived from the conceptual schema based on the user who is going to get data from. Right? So it depends on the user. It is user level, or what we call weave level. Okay. So hope you got a clear idea about these three schemas, right? So this is an sample schema diagram, database schema diagram. So this is a conceptual level schema diagram where it is for human resource and order entry schemas. This is a way how we represent the tables. So there's these tables, job history, and these are the columns inside that table. So these are the relationships. This is one method to represent the relationships. This is called cross-foot method. where there's a cross-foot to represent many sites. This is one-to-many relationship between departments and job history. Okay. In your textbook also, they have given this cross-foot method for ER modeling, but we are learning about another method, which is now being used. But in the industry, they can use both cross-foot method and this is Chen's notation, which we are learning, which is, I think it is more clear because in cross-foot, the relationship is not exactly defined, but in Chen's notation, we use this diagonal shape diagram to represent the relationship, right? So no need to worry about that. You will learn about that in ER modeling. Now, this is one way of representing a database schema, conceptual schema, right? These arrows show the relationships between these different tables. Okay. And there's something called database instance. Database instance means that is the data stored in that database at a particular moment of time, right? Because the data in the database always change over time. When we add data, when we delete data, when we modify data, this data changes. But when we get like a snapshot of your database, that is what we call instance, right? For example, a single table student in the database, that table today has 100 records. So today instance of the database, it has 100, but next day it can be 101 by adding a new column, a new row to that database. Okay, or else one student leaves, or one or two students leaves, and we delete that, remove that records from the database. So that will be 98 next day, right? So that is the one single instance of a database where a particular moment of time we get the data in that database. Got it? Next one, there are three database status, mainly states. First one is define. Define means we specify new database schema. Now you know what is a schema. That is a structure of the database. And then initial state means we populate or load with the initial data. So based on the database we designed on this database schema, we store the data inside the database. That is the initial state with initial data. And valid state means it should satisfy the structure and constraints specified in the schema. So if in the schema it is defined that like here, the student ID should contain integer values, even though you insert data, if there are text values, it is not in valid state. It's only in initial state where you have inserted initial data. But once we satisfy the structure given and the rules specified in the schema, the database will come to the valid state. Okay. Then there's this activity. It may be boring for you to just listen to me. Now you have an activity to do, right? I think you got an idea about what is an entity, attribute, and relationship, and you have learned about primary keys and foreign keys. Primary key is the unique identifier of that table. For example, student table, the primary key would be student ID, or we can get the NIC. Likewise, there can be a unique identifier for each row in the table. Foreign keys you will learn later. Now I'm not going to explain about that. In the next day school we will learn. Now, for now, you have to identify an entity, attribute, and relationship with respect to a university or school library system. Right? I will give you 10 minutes to do this activity. Right? I will put in the chat as well, the activity. And this is a group activity where you need to do it together with other students. Right? Before going to the group activity, do you have any questions from the things which we have learned so far? No questions? So did you get everything, or is everything not clear? What does the silent means? Yes? All clear or not clear? Not clear. What is not clear? With me? Yes? Where did you miss? If something is not clear, you can ask now. Others?
This one, what is HR and OE schema means?
Yeah, that is just an example for you to get an idea about schema, right? Here, this is just an example. HR means human resource, OE means order entity. So these are the two order entry. So these are the two schemas designed for two different divisions in a company. Right? These are the tables which are defined. This is just an example for you to get an idea of what is a schema, right? These are the different tables present in a human resource division, which are which can be useful for a human resource person. And order entry, these are the tables which can be defined. Okay. This is just an example. So don't need to worry about schema now. Schema, for an example, we will learn about ER diagrams. ER is the this schema is usually represented using ER diagrams, which you will learn in the next day school. If this is the part which is not clear to you, don't worry, you will learn in the next day school about ER modeling, and so it will show you this is how a database, the structure of the database is designed before we actually implement the database. Is that the part which is not clear to you? I just explained it very fast because you are going to learn it in the next day's code. Anyways. Okay, so you got the idea about what is a database instance. Is it clear? And database states, is those two clear? Yes. Now I need answers. Are you there? Are you asleep? Okay. So you are there, right? Okay. So we will move on to the activity then, where you need to just define the entities, attributes, and relationships with respect to a school library system. Okay. I will put you, now it's 10:50. We will talk about the case study after the session, right? So now it's 10:50. I will give you time till 11 and put you into groups. Please do this activity. And after you come back, don't leave the session after when you leave the room, leave just the room and come back to the main session. Okay. And then we will discuss about what you have identified with your fellow members, right? So please try to identify as much entities, attributes, and relationships among them as possible. Is the group activity clear?
Yes.
Yes, ma'am. Okay, so this activity is clear, right? Okay. So I will put you into, there are 194 students. I will put you into 20 breakout rooms. So you can discuss with your other friends, okay? And get some answers.
Recording stopped.
Please go to the breakout rooms quickly and
Good morning. Yes. Yes.
Okay, let's go.
Yes. We can get information single. Yes. Yes. නේ අර තුනක් එහෙම ගත්තම අර ඔව් එකක් maybe අනිත් එකේ පොත් ගන්න ඕන බොක්ස් information දාන එකක් yeah. Yes, mate. Oh.
What about the registration number like that? Oh,
Primer. Yeah. Oh. බුක් එකේ මේ අපිට ගන්න පුළුවන් නේද අර ISBM කියන එක ගන්න පුළුවන් ප්‍රයිමරි එක විදියට නේද? මොකද එක බුක් එකකට එක ISP ඔය එකනේ තියෙන්නේ. ඔව්. ඔව්.
For many books, ne? පොත් ගොඩක් ගන්න. Yeah. ඕනේ බුක් වලින්
ඒ ටික තමයි.
ඔය ටික තමයි තියෙන්නේ. එතන ID එකක් දාන්න පුළුවන් book ID එක.
Hope all the students came here. So any of you got the answers for this question? By discussing with your group members? Mhm. Okay, yes. What are the answers? Okay, good. Yeah, maybe the table name and the attributes. Mhm. Mhm. Okay, good. Mhm. Okay, so good. I think you have done a great job as a group. That was Anushat, right? Okay, good, Anushat. Any other? Yes? Yes. Okay, good that you have identified. Yes. But yes, that's it. Hello? You were you?
Can I go through?
Yes. Wait a minute. I couldn't start the recording. Yes.
Recording in progress.
Yes, you can go ahead.
Yes, ma'am. We also chose library as a topic. As far as library is concerned, there are many entities like student entity, books, issues, member entity, address, etc. As far as student entity concerned, we can take student IDs, attribute, then their name, their mobile number, and email ID. Books we can take as attributes, book ID, book name, book author, in a publication, publishers, yes, entities. We can take relationship as far as student to books relationship. We can consider as a one-to-many relationship.
Okay. Okay, good. So you have also identified entities, attributes, plus the relationships. And the other group, group number 2, I think, they spoke about the foreign keys and primary keys as well. That's very good. And any other groups which discussed? No, only 2 groups. Okay. So this time is given for you to speak with your other friends. Okay, so please do the activities. Don't stay silent in the breakout room. That would be utter waste of your time and our time as well. These 10 minutes, make use of the time to discuss with your friends. Even if you don't do this activity, please discuss. And I'm not there, just your friends are there. Just talk with each other. At least ask where they are from, their name. Even I don't care, even though you don't do the activity, please make use of that 10 minutes time which you are given to speak to each other, because you are not physically coming to the university and speaking to each other. This time is given for you to utilize that time to talk with each other and get to know, right? So next time, please, when you are given such a time to discuss, do that, right? Just talk with each other. It doesn't matter the language, but since there are both Sinhala and Tamil students, it's better if you can speak in English so that you can like at least try to communicate in English, right? No one is going to find your faults now. So please do that and make use of that time given to you, right? Next one is this activity 2.4, that is for you to draw a conceptual model for a library system based on the entities, attributes, and relationships which you have identified, right? That you can do at home. Since we have now around 15 minutes time, I'm not going to give you time to do this now. You can do it at home, and there are drop boxes where you can upload your answers. So please do that. Then only you will get familiarized with the LMS, right? All the videos which I have played are given here. You can go and watch it again and do the pre-session activities before the session. After going through the lecture video and slide set, you will be able to do the other activities. So these pre-session activities are basically meant to do based on the previous day's school session. And also some will be on this day's school session after you go through the lecture slide set and lecture videos. Then the day school activity, this 2.3, now that you have done it and you have discussed with your friends, now you can give your answers here, right? So please do these activities, then only you will be familiarized with this course, right? And then, so 2.4, you can upload your answers here. This is, so try to upload answers to a discussion topic, because this will be, yes, the lecture video is something else. This is day school is, I'm doing a separate slide set, but which is also referring the same facts, but also you need to watch the lecture video, right? Lectures, there's a separate lecture slide set where you need to watch the lecture video and then come to the day school so that you can ask questions from me about the things which you already went through. And we can have it as a discussion session, not like a lecture. Okay? Since you are not doing that, I have to do it as a lecture as well. Now, I need you to draw, we will discuss the answer for this question to activity 2.4, but I need you to draw this conceptual model and add it as an image file. This is very important that you do it, because you will be given the lab test to take a photo of your ER diagram. You will be given, this will be an on-site session. I will explain you more detail on day school 3. So please attend day school 3, because there will be a practice session as well to teach you how to draw ER diagrams. Okay, and based on that, you will have the lab test, which will be on site. It is given in the timetable as well. You can get the schedule under this course overview, right? There's the activity schedule and the activity diary. This is the activity schedule for the whole year. And there's the activity diary, right? There's the dates given in the activity diary. See here, there's the ERL1, which is on-site. And for weekend students also, we are having the on-site session. There you will have to come, okay, and do this lab test, and you will have to draw these ER diagrams and upload it to the Dropbox. Upload a photo of your drawing into the Dropbox. So these activities are given so that you get familiarized on how to upload these things and how to get a clear version of your what you have drawn, right? So please do that. Okay, so this is there. You can add a topic, right? You can add a new discussion topic here. And you can give any subject, maybe your name. And then in order for you to upload to this forum, you can add, click on this one, Hope you can see my screen. Click on this add, insert or edit image, and you can browse your upload a file, choose a file from your computer, and then upload the file. Got it? Upload this file. Then your file will be uploaded. By uploading it to the discussion forum, all the other students can also see that, and then they can put their comments if needed. Likewise, you can have it interactively. Yes, I will make it visible to you after this day school session, right? So please do it. And the first lab test will be on site. Okay, if you cannot come on both the days, we will have an online, but it is based on the number of students who cannot come, right? So yes, MS Access, there's an activity 2.5, which was given on day school 1. You have to do it, right? You can do it. And if there are any questions, you can ask. So this is a conceptual model which is a use case diagram, which you will learn in EEX3467 course. Okay. This is not actually designed for a database. It is a very high-level diagram used to define actors and the activities they do. This is for you to get an idea about the overall system, library system, right? There can be users such as students or staff and librarian, and there's a database, right? This part is for the database, but this is so that you can get an idea about each of the activities done by the users. That is the use case diagram. That is also very high level conceptual diagram, right? But what we are going to learn is this one, conceptual or logical design, where we define the schema for each table with column names, primary keys, foreign keys, and constraints, right? So here the primary key is defined by PF and foreign key as FK. Sorry, primary key as PK and foreign key as FK. PF means these act as both primary keys and foreign keys, right? Okay, so please go through this diagram when the slide set is uploaded. These are the tables which in this scenario which are defined for this system, right? This can differ based on the university system. It can have a different set of tables, but still this is a basic general, in order for you to get a basic general idea about a library system, right? There are books and authors, and then books out of loan. Likewise, this is an overall design of your database, right? Yes, class diagram with attributes. But this is a sort of an ER diagram with each of the tables in your database and the relationships. This is also using cross-foot notation defined using that, right? And also there are primary keys and foreign keys defined.
Excuse me, madam.
Yes.
What are those broken lines?
Yes, there are broken lines to represent different aspects, right? But like books, they can have genres, and there can be books without genres. Likewise, so these dashed lines can represent different aspects in different like types of ER diagrams, right? But we are not going to draw this type of ER diagram. This is just for you to get an idea about what is a conceptual design. Okay? We will learn about on more detail the symbols used and the different types of attributes, types of relationships, types of entities in the next day's course session. Okay, just for you to get an idea about what is a conceptual or logical design and how the schema is represented. And this is how you get in Access. Actually, if you go to Access, there's a way you can see the tables likewise by defining relationships. MS Access, I mean. So MS Access is a very general tool to design a database and also to implement. But we are using SQL, using a programming language, which will be used more on industry level. Okay. Okay, before moving on to database development lifecycle, there's some confusion about this on-site activity, right? So this activity 2.4, which I showed you, is for this one. Okay. So this is activity 2.4. Wait. This is the activity 2.4, where you need to draw a conceptual model for a library system and upload it to the forum given in the LMS. Right? Lab test 1. I will explain you more on lab test 1 in the next day school session, because it is based on the day school 3 practice session, right, on ER diagrams. And you can get the dates for the lab test. These are given in the timetable, right? So this will be an on-site activity where you need to go to your nearest center and do the lab test 1, right? So the dates for EEI3266, the dates are lab test 1 for weekday students will be on Thursday, 9th February. And for weekend students, it would be on Sunday, right? So please try to come to this one, because we will do some activities on site, and also then we will do the lab test. And for those who cannot come for the on-site sessions, we will have another online on 21st, right? Make sure you participate on at least on the given 3 days. You can choose one date and make sure you participate on that date. Okay. And lab test will not be repeated. It is a test. I think you can remember what I said about the eligibility criteria on continuous assessment tests. So there are 3 lab tests for this course. This is the lab test 1. Okay. Then we will come to the last part of today's course, which is on database development life cycle, database development process. And there we are going to learn about the waterfall model in software development life cycle, SDLC. So waterfall model consists of 6 steps, right? And we will watch a small video on waterfall model before I go to the explanation, right?
As the new project manager at a software company, your first assignment is a simple software development project. The requirements are clearly laid out, the customer base is small, and the customer is unlikely to change the initial requirements. Knowing several different project management models will serve the purpose. How do you choose which one to use?
'Okay. So this is the waterfall model.
One of the many project management models in use today, the waterfall model is one of the most easily understandable and manageable models. The waterfall model is a project management methodology based on a sequential design process. Much like a waterfall filling lower-level pools, phases in the waterfall model flow from one to another. Also, like the pools filling completely before water spills into the next pool, the waterfall model finishes one phase before another phase can begin. Developed as a software development lifecycle model, waterfall methodology lends itself to projects that are small in size and whose requirements can be definitively determined up front. A simple waterfall model has 6 phases: requirements, design, implementation, verification, deployment, and maintenance. Let's go through each, starting with requirements. Because the waterfall model mandates that requirements be well documented before any other project work can begin, this phase is emphasized, and the project manager is likely to spend more time during this phase than the others. Gathering requirements starts with the concept, or the idea of what the customer wants to do. The project manager will discuss the concept with the customer, with subject matter experts, and with other stakeholders to define very specific business needs the software will address, problems the software will resolve, and functionalities the customer desires. These requirements are captured in the requirements document, and the document is approved, closing the requirements phase before the project team moves to the next phase. With the requirements in mind, the project team designs the software to meet the stated business needs and solve identified problems. The design phase includes the logical design and the physical design. The logical design is an abstract representation of how the software data flows, the inputs and the outputs. It is often shown graphically as a diagram showing data flow. The physical design determines the hardware, such as storage and network hardware, which will make the logical design a reality. Once the design is fully complete, the project team will review and approve the design. Implementation cannot begin until the design phase is formally closed, with the approval of the design document. Once the design is approved, the implementation phase begins. Contrary to its name, the implementation phase is not when the software is implemented into the user environment. Rather, the implementation phase is building the design into actual software. During this phase, the software programmers do the actual coding to build the software according to the design document. As with all phases in the waterfall model, the implementation phase must be complete before the next phase, verification, can begin. Often, software is built in units and integrated into a whole at a later point. This allows for ongoing implementation and verification. As one software unit implementation is complete, it is sent to verify.
Recording in
Deployment phase
progress.
is the actual release of the new software into the information technology environment. As with the implementation phase, the deployment phase may be broken into units to allow for ongoing deployment and maintenance phases. For example, the software may be deployed by location. Once a location is fully deployed, it would move into the maintenance phase, while another location begins the deployment phase. The maintenance phase, often referred to as a stabilization period, is the phase of the project in which initial issues are resolved. The customer provides feedback on the new software for the project team to look into. Additionally, the project team may do additional testing in the live environment to verify acceptable deployment. As our new project manager doing a simple software development project discovered, the waterfall model has clear advantages. However, it does have disadvantages, and it is not suitable for all projects. Let's go over advantages first. The waterfall model is easy to understand, easy to manage, has fewer production issues, and offers better budget management. However, it's not flexible and doesn't handle unexpected risks well. It's also not a good model for complex or long-term projects, and it can be difficult to capture all requirements up front. The waterfall model is a sequential project management methodology where one phase completely finishes before the next phase begins. There are 6 phases in a simple waterfall model: requirements, design, implementation, verification, deployment, and maintenance. The waterfall method is easy to understand and manage, results in fewer production issues, and is easier to keep on budget. The disadvantages, however, are that it is inflexible, not suitable for complex or long-term projects, and it can be difficult to capture all requirements up front.
So hope you got an idea about the waterfall model based on that video. And there are different types of defining these phases in the waterfall model. As in the video, it was given the requirements gathering and there was no analysis. But here we are going to learn about requirements. That means requirements gathering. So first you need to gather the requirements and then you need to analyze those requirements before we go to the designing phase, right? Before we design the system, we need to analyze the requirements which we gather. And there are many methods to gather the requirements, like we can distribute questionnaires, we can interview people by observations. Likewise, there are different ways we can gather the requirements. And then we can analyze the requirements and then design the system. Then we implement our system. Implementation is done. And after implementation, there was deployment. Deployment means releasing the system and then testing. But you can, after implementation, there's testing. You need to do the testing. And then there was deployment in that video, right? But here there's only maintenance. You can put it as deployment and maintenance both together, but there are only 6 phases defined in a waterfall model. Okay, so it's only maintenance here. Maintenance means you have to maintain the system, right? There are updates, security updates. So there are so many things. After testing and the deployment is done, we have to do as maintenance. Okay. So these are the 6 phases we are learning, but there can be different, in different books, there can be different 6 phases given as the waterfall model. But what you can get the idea is that there's these basic 6 phases, and for this maintenance, you can add the deployment as well, where you release the product and then maintain. Okay. And this is the database life cycle, where there's, so this is a waterfall model, and based on the waterfall model, we have the database life cycle. So why we are using waterfall model for database development? Other than any other, there are so many other SDLC methods, like agile method is there, object-oriented, there are so many other methods. But why we are using waterfall model? Can any one of you guess? What is the main thing of using, what is the specialty of using a waterfall model?
It's simplicity.
Okay, simple, yes. What else?
Easy to proceed.
Easy to proceed. And what is the main thing, factor about the waterfall model?
Can implement with a low budget.
Okay. And?
Accuracy.
Yes.
Good structure.
Yes. So that is exactly. So in order to move to the next step, the previous step should be completed. Then only you can move to the next step, right? In a waterfall model. It's like a waterfall. Okay. So first you have to get all the requirements gathered. Then only you can analyze them and then design the system. Right? So you can't go backwards. You can't go again like this. You can't go again from the design phase to requirements. Usually in other systems, it is possible, but not for this system, because once you develop the database, it is developed, right? You can't go back and again gather the requirements and again develop the database. That's why this schema or designing the structure of the database is very important, right? Because once you have developed it, it is developed. And when you enter the data also into the database, it is really difficult to change the structure of your database. You will get to know when you are implementing it actually using SQL, how important the designing is, right? That's why we are using the waterfall method, because you have to make sure that you have gathered all the requirements and you have analyzed it properly, and then you have designed the database properly before going to the implementation. And even after implementation, you have to test it properly before deploying it and maintaining it. Okay. Before releasing it to the customer, you have to make sure it is tested properly. Right? So first, you have to establish your requirements. In a database, first you have to establish the requirements. And then you have to analyze and develop the conceptual data model. Okay, based on the conceptual data model, you design the database. Afterwards, using the logical schema design, you have to implement the database. After that, based on the initial schema on which you have implemented the database, you have to test it. And after testing only, you can release the schema, and then the maintenance phase, it is done repeatedly. Unlike these phases, maintenance you have to done repeatedly, because always it needs to get maintained. Okay. And if you have gone through the lecture slide sets, so these steps have been explained one by one clearly, right? So if you haven't gone through the lecture slide sets, please go through them, and you can go through the video also. So here it is explained the requirements gathering phase, data analysis phase, database design, implementation, testing, maintenance. All these phases have been explained there. So please go through them. And since it is really easy, I'm not going to explain the steps, phases, 6 phases again. And if you have any questions after watching the lecture video, you can put them in the discussion forum for this day's course. And that comes to end of today's session, right? Do you have any questions regarding the SDLC? No questions. Okay.
Recording stopped.
Then